Okay. So, percent, uh, So this is an overview of the programming language named Kotlin. Kotlin is designed for clarity, safety, and interoperability. It was kind of a successor to Java and has a lot of features that are similar to Java. It's becoming one of the top choices for Android backend and cross-platform developments. Um, it is it was created for the shortcomings of Java and to help kind of fix those mistakes that Java has since it was created a few decades ago.
Now let's start off by diving into a bit of the history behind Kotlin. It was created by JetBrains in 2011, which is the same company that created IntelliJ IDEA, in which at the time Java was the most popular languages used back then. However, developers were frustrated by it because of uh, because of many syntax errors that it provided. There was a lot of redundant code, repeated lines throughout, in which angered a lot of developers, especially the lack of safety features that it provided. And JetBrains wanted something that could improve productivity while being interoperable with Java. So they built Kotlin, in which in 2017, Kotlin hit a major milestone as Google officially endorsed it, which increased its popularity. Many developers started to use it, especially with Android, creating Android apps. But and it quickly became the preferred language for that. However, today Kotlin is not only not used for mobile apps, but it's also used for web end development, desktop software, and backend services, which is it's due to this ability to compile JavaScript and other native binaries.
So Kotlin is a statically typed language, which means the type checking is done at compile time, similar to C++ and Java. With Kotlin being kind of a successor to Java, it does use a JVM, which is Java Virtual Machine, and that can compile into JavaScript and native code languages. It was also, like I said before, is designed for Java shortcomings, and those shortcomings are to reduce boilerplate code, enforce a null safety, and include extension functions and coroutines. Boilerplate code is pretty much just repeated code snippets in multiple areas of your class or project.
Now, when comparing Kotlin to other languages, like let's take Java, start off with. When comparing Kotlin to Java, the first thing you notice is that Kotlin is much more concise. Kotlin, as it creates fewer lines of code to achieve the same functionality, and that reduces both development time and change and the chance of introducing bugs. For example, a line of getters and setters for Java can take over 30 lines of code. However, in Kotlin, it could take five or less amount lines of code. Uh, that is null safety is one of the biggest and most praised advantages of Kotlin over Java. Because in Java, one of the most common sources of runtime errors is null pointer exception, which I've run into countless times when creating code, and it's frustrating to deal with. In which it's when your code tries to access or modify an object that hasn't been initialized, which is something that crashes countless programs every day. In which Kotlin fixes this at the language level, as by default, variables in Kotlin cannot be null unless you explicitly say it in the code by adding a question mark, which means if you try to assign or access a nullable object without handling correctly, the compiler won't even let it run. Which, which just while this is a small change, it can drastically make the code more stable and bug resistant, especially when you're working with large scale projects.
So Kotlin also has functional programming, meaning it supports first-class functions, lambdas, and higher-order functions. Higher-order functions pretty much just give you the ability to pass functions to other functions. Um, Kotlin also has coroutines in a sequential style that doesn't use callbacks. Um, it uses an asynchronous approach opposed to Java's traditional approach, which helps with saving memory and on computing per thread. Um, Here are just a few examples of the conciseness with the data class examples and smart cast examples. And the smart cast examples, an example, the object is string is just typecasting. So you're changing the type that it is. The programming or the functional programming example is just showing the dot filter, dot maps, and the chaining operations that you could do. To do this in Java, you would have to implement a stream, which adds more lines of code, which emphasizes the conciseness that Kotlin has over Java even more. That is just a basic how to write a coroutines for uh, Kotlin and shows that there's no callbacks and that looks synchronous, but it's not blocking.
Now, I'm looking at another language, C++, and comparing it to Kotlin. These two are very different in terms of purposes. As C++ gives you low-level access to memory, letting you work with pointers and manual allocation, which makes C++ more powerful in terms of performance, especially things like game engines or operating systems. But but due to this, it also makes it easier for critical mistakes like memory leaks, buffer overflows, and segmentation faults if not managed correctly. And let's just start off with memory management. When it comes to memory management, Kotlin and C++ takes two very different approaches. As we said earlier, Kotlin runs on JVM, which includes a built-in garbage collector, which means the system automatically handles memory allocation and deallocation, which cleans up objects that are no longer being used, in which as a developer, you don't have to manually manage memory, which makes development faster and less error prone. But on the other hand, C++ uses manual memory out management, which while it does give you more control, but it, however, it also introduces a much higher risk for mistakes. As in C++, you have to use pointers to allocate memory dynamically, and you're the one responsible for freeing it once you're done by making sure the computer deletes it. However, if you forget or mess it up, you can cause memory leaks, which can end up crashing your computer or even security vulnerabilities. And then concurrency is another major difference, is that Kotlin uses coroutine, which allows you to write asynchronous code that looks and behaves like synchronous codes. Well, in contrast to C++, it uses threads and mutexes, which are powerful but very complex to work with.
So Kotlin is similar, not similar, but compared to C++, you have the performance and computations. So Kotlin has the speed of Java with the faster builds, but C++ has a faster runtime and slower compile times. Uh, Kotlin also has safety over C++. As mentioned earlier, there's no pointers, so you don't have to worry about memory leaks as much. I'm sure there's some garbage collection that it fails time to time. There's also no bound checked collections. C++ is also vulnerable to buffer overflows, and as mentioned, memory leaks with the dynamic memory allocation.
Next up, data type. You have your basic data types as all other programming languages, numbers and their unsigned counterparts, booleans, characters, strings, arrays, lists, float, doubles, sets, maps, just your basic data types. And with Kotlin, there's three special types. An any, which is a generic type to indicate that a variable or function parameter can hold any type of object. Nothing, which represents a value that never exists, and unit, which represents the absence of a value, similar to void in Java.
So with these data types, just using them in code, you can have embedded variables. So what does that mean? An example would be uh, the, this this little one line of code down here, where you have a message value that equals hello, and then you have a $ name, to where that $ name includes the variable inside. And that $ with the brackets item dot size includes the size of the item uh, array. So you don't have to use all these plus signs when you're creating this message value. Um, so why would you want to choose Kotlin? You have these extension functions which allow you to add methods to existing classes without inheritance. And this helps with not really having to create those broad and very not really abstract, but those broad uh, functions that can be used everywhere, but they're so broad that you have to keep them to where they can be used by multiple things. It also has DLS support, which allows you to build domain-specific languages with the clean syntax. An example of this would be the second example with the DSL support with the HTML, where you're writing it with clean syntax in the for the HTML generation. Um, it also has sealed classes which define restricted class hierarchies for better Win expressions. Win expressions are just supercharged switch cases. In Java and C++ alike, they just replace those if-else, long if-else statements with a condensed version. Um, there's also multi-platform projects which give you the ability to share code between Android, iOS, and web using the multi-platform that's provided with Kotlin. So just an example of the steel classes and multi-platform projects are the second half of that example.
When you Now you may be asking when should you choose Kotlin over other languages? And for starters, when you're looking into creating and developing high-level apps for Android and web backend, it's better to use Kotlin as it provides more developer productivity more than low-level control. And also, as Kotlin also has fast build time and modern syntax, which make it ideal for projects that require rapid iteration and constant update, which is very good for apps as they need to be constantly updated to keep information up to date and stuff. And when it comes to developer productivity versus low-level control, Kotlin is the way to go. As while it may not replace C++ in terms of performance critical areas like embedded systems or game engines, it excels in applications where speed of development and safety are key. So if you have like on a time crunch for your project, Kotlin is the way to go for you. And Kotlin is also great for cross-platform projects, as it uses Kotlin multi-platform, which allows you to share business logic across Android, iOS, and desktop applications, which is a game changer for companies that want to maintain consistency by reducing duplication of effort. And lastly, if you're choosing between Kotlin and Java, and conciseness is more important for you, Kotlin wins almost every time, as we discussed earlier. For code in Java, it could take like 30 lines of code versus Kotlin 5 or 6 lines of code.
So an example of that conciseness real quick would just be this top example here. that's highlighted. So you have your Java where you have this public class of just basic my class, and you have this private my field variable, and then you got to create these different public functions. And while you could condense this, writing them in line, the a lot of times they're written in this way that you use three lines of code. And then you come down here to the Kotlin and it writes almost the whole class in the size of two of the functions. So it halves, if not a third, of the code space that you would use for Java, and you can still read it almost just as well as Java. Um, so in conclusion, when would like yes, Kotlin can be better for better than Java if you want more concise, that null safety, and a more modern language. Um, as mentioned earlier, Java was created a long time ago. It's one of the more original language that was created when computers and stuff started becoming a thing. So when would you can use Kotlin over C++ when you want the safer and faster development, especially for those higher level apps. Uh, Kotlin also has a unique strength of extension functions, coroutines, and a multi-platform support. Um, Now, Kotlin's not just this one above all that's just better in every single language. Otherwise, it'd be taught in every single class. Not every single class uses Kotlin, so it's clearly not this one above all language. So there are some examples of where Java is better than Kotlin, and this is a snippet of code. It's a high throughput trading system, and it's a snippet of a similar uh, code that's actually used in the real world. So you can see where Kotlin condensed the Java majorly, but there is a problem. Kotlin's garbage collector is unpredictable, making it not suitable for this type of work. Uh, the actual real-world use function is the Goldman Sachs Slang platform, which processes over $1 billion in trades per day. Um, Similar for C++ is better in this example for 3D physics simulations as it has a faster runtime with the low latency on calculations. The real world example would be the Tesla self-driving cars sensors. They use a C++ stack, and the C++ had 1 millisecond latency, and with Kotlin, they just couldn't get that latency time down to that. So Kotlin just wasn't feasible in that sense. So an overall main demo would be this medium level program. So
This is our demo here. It introduces a data task, which we outline all of our variables here, and it goes and creates this task manager class, which starts off by adding a new task to the fun add task function we have here, which creates a new object, which it provides it with an ID, a title, and description, and it goes on to allowing the computer to print it. And then when it comes to completing the task, we have this function here called complete task, which we created to change it tests the boolean to see if it's true or not, and if it's true, then the task is completed and shows completed next to the task.
so this is the filter that is used to filter the task, whether it's completed or not, because they use a Boolean. So it just compares the Boolean to whether it's true. Um, then you got your display task that just displays all your tasks when it's called. It doesn't do it based on whether it's completed or not. Uh, actually, this bottom one is the one that just prints a full list of tasks. The top one is displaying it based on the filters. Then we run the main, we add our three tasks of buy groceries, finish Kotlin presentation, and to call mom. We pass in, of course, the titles that were just read, and then a description for each one of them. We don't have to add the Boolean because when you add a task, they're all automatically marked as false because they're not completed instantly. So once we do that, we print all of our tasks out with the display task, and then we'll go down, we'll complete task number 2. And after we do that, we should have 2 pending tasks and 1 completed task. And then we print them out, and after we print and run this, we can see that all of our we see that all tasks are added, all tasks are printed, 1, 2, 3, with the correct title, description, and the status. This line right here is where we finish task number 2, which was the Kotlin presentation. And then when we print it out again, we had 2 pending tasks, buy groceries and call mom, and 1 completed task of the finished Kotlin presentation.
And that is just a demo of what the Kotlin for can do here, in which you can see it's more concise, more a lot less lines of code. With in other languages like Java, it would take a whole lot more because you have to create all of those setters, getters, and stuff like that. And so, in conclusion, as you can see, Kotlin has its strengths and advantages over Java and C++ as it's more concise, null safety, modern, and it's more safer and faster developers and develop. We, if you have any questions, feel free to reach out or comment in the comment section. Any questions? And yeah, thank you for listening.
Just a quick note, real quick. This bottom little site here is a site you can go to where you can code in Kotlin without having to download any type of IDE. So that's a quick way if you just want to code in Kotlin. You can go to that site and it lets you code. So thank you for listening, and that will be it.